Alright, welcome to part 4 of the speed of reaction. Okay, so now we're going to focus on data and the graphs. Okay, more particularly on the graphs. Alright, so now let us recall what we learned in part 1 to part 3. We recall that steeper gradient represents faster rate of reaction. And the 4 factors that affect the rate of reaction were pressure, temperature, concentration, and particle size. Okay, we also learned in previous chapters how to identify the limiting reactant, and we also learned in part 1 to 3 that limiting reactant will determine how much product is formed. So let's look at example 1. 3 examples were carried out to measure the rate of reaction between excess powdered calcium carbonate and dilute acids. Okay, in experiment 1, 25.0 cm3 of 1.5 mol per dm cube hydrochloric acid was used. A further experiment 2, using hydrochloric acid was carried out. The results of experiment 1 and 2 shown on the graph. Okay, so in experiment 2, the concentration was not stated, so that's why the question is asking for the concentration used. Right, so first step, we need to identify the limiting reactant. Okay, so once you have identified the limiting reactant, then you know whether the yield has changed or not. So in this case, the yield is okay. In this case, the excess is powdered calcium carbonate. Alright, so therefore, the limiting reactant was the hydrochloric acid. So any change to the hydrochloric acid, okay, will result in a change of yield. Okay, so now let's look. In experiment 1 and experiment 2, the yield or the product has decreased by half. So experiment 2, okay, product decreased by half. So when your product is decreased by half, it means that your acid will most probably have decreased by half. Okay, so volume of product formed is different. Why? Because the limiting reactant, which is your acid here, has changed. Okay, so if the yield is decreased by half, acid is decreased by half, so therefore your concentration would be 1.5 divided by 2, which is equal to 0.75 mole per dm cube. Okay, so I want you to highlight this part. If the number of moles of limiting reactant is changed, the number of moles of product will change accordingly. So if limiting reactant was halved, the product will also be halved. Now, why do we Okay, example 2. A student carried out an experiment to investigate the speed of reaction between lumps of 5 grams of calcium carbonate and excess 1.0 mol per dm cube hydrochloric acid at 20 degrees Celsius. The mass of contents and the conical flask was measured at regular intervals. So, if you look at example 1, what we're trying to teach you here is When you change the limiting reactant, the product will change. So if you halve the limiting reactant, the product will also be decreased by half. Okay, so that was example 1. Now we're looking at example 2. Example 2 now allows you to practice the other parts in a math. Okay, now let's look at example 2. Alright, so you have all the conditions: 5 grams of calcium carbonate, excess 1.0 mole per dengue of hydrochloric acid at 20 degrees Celsius. So these are all the conditions, right? So sketch a graph to show how the mass of carbon dioxide produced varies with time. So here, if you're looking at drawing or sketching the graph, so let's look at the criteria for success for the graph, and then we'll draw according to the criteria for success. Okay, first, I must be able to draw the x and y axis. So let's look. X and y axis. I'm gonna try and see whether I can use a ruler here. Okay, please make sure you use a ruler. Okay, it's not that straight. It's the best I can do. Okay. Alright, please make sure you use a ruler for this. Okay. Next, I'm able to label the axis accurately with units. So, I need to draw loss of loss of content. Slash grams, and then you go, and this is time per minute or seconds. Alright, next, let's just look here. I'm able to indicate on the graph the point of origin. Now this is important so that we know where is 0. Okay, so this is 0, is the point of origin. Next, I can draw the graph of decreasing mass. Decreasing mass means I have decreasing gradient, and the gradient at the end of the graph is 0. Okay, then I also know that my graph should not reach y is equal to 0. Right, because there's still some reactants left behind. So let's draw here. Right, so you will start from here, and it should not touch this at all, this line at all. So maybe put it here. Okay, so I will draw a straight line first. Okay, to show that gradient is 0. So this is gradient is 0 at the end. Then I just join the two parts together. Oops. So this is decreasing. So this part must. So this is decreasing gradient. Let me change the color. Right, decreasing gradient. And this is gradient equal to 0. And as you can see, it does not touch y equal to 0. Okay, next. So I have all of this. Once I have all this, please tick. Alright. Next, what happens when I change certain variable, certain conditions? Okay. So number 1, when lumps of 5 grams of calcium carbonate and excess 1.0 mole per dengue of hydrochloric acid at 60 degrees Celsius. So now let's look at the original lumps. So lumps are the same. So what I want you to do now is take a red pen or a different color pen or a highlighter even, okay, and try to circle the parts that's different. Okay, so now let's look. So lumps is the same. So take 5 grams is the same. calcium carbonate. Excess is the same, 1.0 mole per dm cube is the same hydrochloric acid at 60 degrees Celsius. So this is where it's different. It's a higher temperature. So I will write the factor here, temperature increase. Oops. Alright, so let's focus on one first. So when temperature increase, what happens? The rate of reaction will also increase. Alright, so when the speed increases, if you remember the case study, okay, what happens when speed increases? The reaction will end earlier. So here we will put, oops, sorry, my eraser is not very good. My ruler is not very good. Okay, let's try and draw again. I'm using a different color pen so that you guys can see. But in reality, in exams, please make sure you use a pencil. Oh god. Okay, so alright, draw the line. Because only temperature is changed, limiting reactant is not changed. The end product should also the volume, the loss in mass should also be the same. Okay, so here all I have to do is to join it up. Okay. Please make sure it's all nicely joined. Alright, so this is graph 1. Okay, so as you can see, with higher temperature, it ends earlier. Okay, and it has a steeper gradient. Next, lumps of 5 grams of calcium carbonate. Okay, so let's take lumps, 5 grams, and excess of 0.5 mole per dm cube. So this is where it's different. The concentration is different. But let's check. Was acid the limiting reactant? It's not. So the limiting reactant here is calcium carbonate. So limiting reactant is calcium carbonate. Okay, so this is important so I know whether or not the product will change. So even if I decrease the concentration of hydrochloric acid, product will not change because my limiting reactant is calcium carbonate. Okay, so all it will do is it will make the rate of reaction slower because concentration has decreased. So when rate of reaction is lower, it will end later. So I will use green color. So perhaps I will end somewhere here. Okay, so somewhere here. All I have to do is join it up again. Okay, that's it. So this is graph 2. Alright, now graph 3. Lumps, and this is powdered. So the difference is that it is powdered. So powdered means the particle size is different. Particle size decreases, surface area decreases. Surface area increases, rate will then increase. Okay, so again, all I have to do is to make sure since rate is faster, it will end earlier. So maybe somewhere here, and then just draw out the. Okay, so again, this ends a bit earlier. 1, 2, 3. Okay. Next, lumps of 10 grams of calcium carbonate. So the difference here now is 10 grams of calcium carbonate. And let's recall, limiting reactant is your calcium carbonate. So if the amount of calcium carbonate changes, your product will change. So how much did it change? So twice, right? So it should be approximately twice somewhere here. Okay. And maybe end somewhere here. And then just connect the two. Okay, something like that. Right, so this is right. So because the product is twice, the volume should be twice, or the mass should be twice. Okay, and it should end later. Okay, so this one and later. Product twice as much. Okay, so that's example 2. Alright, now let's look at example 3. Student carried out experiment. Okay, the same thing, but now it's with magnesium ribbon. Okay, construct an equation for the reaction above. So let's look at this. A magnesium ribbon plus, was it hydrochloric acid? Yes. Hydrochloric acid will give me magnesium chloride plus hydrogen gas. And that's it. So this is NaSH. Okay. B. Sketch a graph to show the volume of gas produced varies with time. So again, the same thing, but now we're talking about volume of gas. So let's draw the X and Y axis first. Okay, so volume of gas cm cube per minute here. Okay, next I'm able to indicate on the graph point of origin. Okay, so I put 0 here. Then next I can draw the graph of increasing volume. So highlight increasing. For volume, it increases, alright? And then I should also know that my graph starts from 0 because there's no gas at the beginning of the reaction. Okay, gas will only start to be produced after the reaction has started. Okay, so again, decreasing gradient, and the gradient at the end of the graph is 0. So maybe, okay, let me take my ruler. Okay, so maybe somewhere here. Okay, gradient is equal to 0. Alright, in decreasing gradient, and start from 0. Start from 0, decreasing gradient. Okay, so this is the graph. Okay, next. Student repeated the experiment a few more times, changing one variable at a time. So now let's compare. Okay. So let's just rate first. Okay, let's just compare. Right. Excess magnesium ribbon and 1.0 mole per dm of hydrochloric acid at 20 degrees Celsius. So we still have the same excess magnesium ribbon, 1.0 mole per dm, still the same, of hydrochloric acid at 60 degrees Celsius. So the temperature has increased. So increased temperature, increased rate, gradient will be steeper. Okay, so again, if you increase your rate, you will end earlier. So here goes. Alright, ends earlier. A bit shaky there. Okay, it ends earlier. Okay, so label this as part 1. So now let's look at part 2. Excess magnesium will make 2.0 mole per liter of hydrochloric acid. So now we know that your hydrochloric acid is actually the limiting reactant. So because it's the limiting reactant and concentration, okay, increases by 2 times, okay, the product will also increase by 2 times. Okay, we just refer back to the first page. If limiting reactant was half, product will also be half. So if limiting reactant was increased by 2 times, product will also increase by 2 times. Okay, it's proportional. Right, so we'll increase 2 times. So here we just draw about like that. Right. Oops. Now where it ends, you're not going to be tested on that. Okay. So let's okay, so now start from 0. Oops. Okay, and yes, so this is graph number 2. Let's look at number 3. Alright, so if you look at number 3, the concentration now has been halved. So if it's half, by 2, okay, so halve it. So maybe around here. Okay, and join the line. So this is 3. Next, 4. So excess magnesium powder. So now the difference is there is a powder, smaller particle size, which means more surface area. Okay. Which means a faster reaction. So all I have to do is to make it faster. So maybe I can make it really fast. So you must make sure when it's faster. Okay, so in conclusion, when the reaction is faster, it must end earlier. If limiting reactant changes, the product changes. Okay? Right, so that's about it. Okay, try the questions in your worksheet and we are done. Thank you. Bye-bye.